Alright, so welcome back. So in this wonderful and exciting tutorial, we built in this wonderful app, which is an image color analyzer. So this is going to be used to give us a distribution of the colors within an image, right? So let's explore it. If I come back here, I can drag and drop in an image. So let's drag and drop in a simple image like this. On to create, I'm going to read this particular image, right? Analyze it and then give us the distribution of the colors within that particular image, right? Very nice. So that is the basic idea behind a very simple app. Try to see how to build this one from scratch using Streamlit. Perfect. So if I come down, I scroll down to here, you can see that out of this image there's a lot of white, some mauve or pink or purple, with some black and some grayish color, right? So the colors here do not correspond, as I said earlier on, because plotting doesn't support all the colors. But as you can see, this particular label here is the highest, which is FE, which is a form of white, because FFF is white. And then you see you have the other colors also, right? The different distribution of the colors, as you can see from here. Then if I come down, you can also see the color has distribution. Very cool, very nice, right? You can see also the distribution, the actual result, because we scaled them. That is something very basic. You can actually expand this to see it clearly. There's the power and the beauty of Streamlit. And you can see that if I hover it, you can see the result. You can click on this. You can take that one out. You can see that now I'm taking that one out, right? So I can also take this one out, right? Perfect. All of these things is coming from Streamlit, right? Out of the box. Very cool. Very nice. Cool. Okay. That's something very basic. Now, so in case you want to build Streamlit, you can just go back to the official website and then download Streamlit, right? So that is something very basic. So let's see how to work and build this app from scratch in the tutorial. So I just go back again to our workspace. I'm going to go back to my app. Let me stop the old app that was running. So this is the app that is running, and I'm going to stop this one out, right? So get out of here, and then let's move into a directory. So let's call this mkdir. Let's call just challenge, right? So this is Streamlit challenge. Okay, so let's build our first app. So we're using WebGenesis to help us spin up something very basic. So in case you don't have WebGenesis, you can just install it with pip. But it's not important, right? You can just go straight away with creating a file. So touch app.py. Then go to open that touch app.py. You can also use WebGenesis to make it easy for us. But to save us time, I prefer to use WebGenesis. Okay, so it's taking some time for it to open. Perfect. So we are building this image color analyzer. So I think it's better if I put it inside the folder, right? So go back again. Let's make a folder and put it inside. So let's call this image color analyzer. Here you can make it small case. Right, and I'm moving to the image color analyzer, create a file called app.py. Right, so we are no more using this one, we are just to make it easy for us. Right, so let's open it with Sublime, and then from there we can start writing some code. So it's going to be very simple. This is it, right? This is a completed one, so we start building it from scratch. So let's check it out. So I'll just go back again to, you can use VS Code, you can use Sublime Text, but I prefer VS Code or Sublime Text, right? I prefer Sublime Text because it's fast and lightweight for me. Okay, so let's see what we want. I'm just going to go back again. I'm going to position my browser. So this is the one we're building at the end of it. Let's position it beside it, right? As you always do. Perfect. So let's start. So I'll just go back again, right? And I'm just going to import the core packages. So in case you don't have Streamlit, as I said, you can just go back to your terminal and just go with pip install Streamlit in case you don't have it on your system, right? Perfect. So I'll just go back again to our workspace and we're going to start writing some code. So let's go to our core package. I'm going to import Streamlit. So we import Streamlit as st. Perfect. Now Streamlit can be used in the format of anyhow you want it to be. All you have to do is that to make sure that you are passing whatever you want to display with the st command, right? Now I prefer to go with this option, so main, which makes our work easy for us. And I'll pass in all the code that I want to pass in here. So all the code will go here, then I'll just go with if main. I prefer this approach because it makes it easy. For now, we do not have multi-page app support, but it is in a pipeline, right? It's in a pipeline, so stay tuned. It's very cool, right? Very, very cool. I've seen it. Okay, so let's see how it is, right? So now I'm just going to create, as I always do, so st.title. Let's give it my image analyzer or color analyzer, right? So now, perfect. So for this simple code, in case I want to run this simple code, I can just come back again to this place and just go with, after installing it, same location that we have. Let's go with Streamlit run app.py. So this is going to use Streamlit to run this particular app. That is the meaning of this command. And by default, it's going to use your default port browser, right, to spin up and run this app. Perfect. So it's going to be using this particular browser, my default browser, or you can just copy this link, right? Go to your browser and then paste that particular link there, right? So it's using my default browser to open. So let's wait. Perfect. So you can either copy this one or allow it to open. So I've copied it and I've pasted it here, right? 8502. Perfect. So with this simple code, we can see that we have our code here, right? st title image color. And you can see that this particular image color is very huge. So if I go back and I inspect it, so right click, go with inspect, you can see the actual HTML code behind the scene, right? That is the power of Streamlit. So you just write your Python, you add some Streamlit magic to it, and then Streamlit makes it happen for you. So that now this is the HTML CSS that has been added to it. I don't know whether I can see it. Apologies here. I hope you can see it here, right? So if I come back here, you can see that it has given us in a very nice format, right? Image color, right? So Streamlit added all of this code for us, right? This was what we wrote, and then Streamlit added all of this code behind the scenes for us. So as you can see, it is using HTML CSS, right, to render our work for us. Very cool, very cool. That is the power of Streamlit. Now let's go back again and then let's build our app. So apologies for how this tutorial is going to be. Perfect. So let's move on, right? So let's add some menu. So I want to add some menu to it to give it a sidebar. So this is going to be my home and then my about, right? Something very simple. Then to just work on it, I can just go with st, right? St, I can just go with my choice, which is going to be st.select sidebar.select box, right? And I'm going to pass in my menu, then this particular menu. At the moment I do that, it's going to automatically generate the sidebar for us. So it gives us two options. Anytime it sees a change in a file via an identifier and then watchdog, you can rerun it. You can also always rerun, right? Perfect. So by just adding this st.sidebar, we have gotten this sidebar beside it, right? You see that our menu is there. So we have the home and about. Perfect. So as we always do, so if the choice is equal to home, I want you to move to the home button. So maybe in the future, because of the multi-page support, we will have to use a different approach, right? So when it comes, we'll move on to that. So this is going to be my choice. Then let's go with st.subheader. Let's call that my home page, right? And then else, that is in case it is not home, I want you to go with st.subheader for the about page, right? So we have two sides or two sections of this app. Now let's create a form or a place to receive the image. So this is going to be the place we want to receive our image. So let's put as image file, right? Then st.file uploader. We need to pass in the image, so upload file, so upload image. Then let's specify the type of image we are supporting. So out of the box, I want to support PNG. I also want to support JPG, and then I also want to support JPEG. So these are the type of images I want to support, right? If I save it and I come down, automatically it's going to give me this Dropbox. Very nice. Now, since the Dropbox has come, let's pick the particular image. So this particular Dropbox here is, or file, I said Dropbox. Here, drop option is very powerful, right? So you can actually, it's going to operate like a binary file, so you can actually work with it like a binary file, right? So it's going to be if my image file is not none, right? So in case it's not empty, I want to start processing it. So let's process it. So we're creating a simple function to load the image, and then let's load that particular image, right? So let's go to pass. Let's save it. Now let's come back here and let's paste in some other utility functions, right? Or packages. I'm going to paste these packages that we're using to save us time. So let's take out this. So we're using Pillow to help us open our file. We'll not be using these ones. Okay, so these are the things that we'll be using for now, right? We'll be using Pillow to help us read our file. These are going to be used for our plot as well as creating our data frame. This is going to be used for machine learning activity because we want to get the color distribution, and then the best way is to use clustering, right? Unsupervised machine learning clustering, so using KMeans to help us get the proportion of the colors, and then these will be used to plot it, right? And we'll be using OpenCV to help us load it. So let's use OpenCV. You can actually use Pillow to open the image, but anyhow you want it to be is up to you. Okay, so let's create a function to load the image. So I'll call this my utility functions. So def load image, which is going to pick in the image file, right? To take this image file that you are supplying, and then when you take the image file, I want you to open that particular image using Pillow. So open and pass in the image file. Then I can now return this image, right? It's a simple function to load the images. So I'll just come down here, and then I can just go to my image, load image, I pass in my image file, and then I can use Streamlit to render it with the image option. So with the image option, you can also specify the width of it, right, if you want. So let's try it out. So I'm just going to go back here, pick an image. So let's pick a simple picture. So I'll be picking this particular picture here to see whether it's working, and I'm going to drop it in our app, right, in the drag and drop. So we had it here, so let's drag and drop it here. So that this is the JCharisTech logo, and now the image is there, right? So that means that the app is working perfectly well. Okay, so we have gotten the image. Now let's do some analysis. So this is where we'll be doing some various analysis. Transfer analysis. Now let's get the image. So let's get image Pillow. So how do you get the image Pillow? So there's a simple way you can get the image Pillow using Pillow itself. So this is going to be a simple function. I'm going to create this function called get image pixels, right? Which is going to take the image file. Then you'll be opening it in a different way. So let's go this with image.open. I want you to get the particular image file. So let's call this one as file name, right? File name, so that it looks different. It's still the same thing anyway. File name as RGB image, right? Then I want you to get the image pixel. So image pixel is going to be my RGB, right? Then I'll just go with my get pixel. So in getting pixel, I can just specify that I want 30 by 30 by 30. Very simple, right? Just to 30 by 30. So it's going to give us the pixel of our image, and now I can return that image pixel. So let's return it. So it's going to give us the image pixel. So I just come down here, and then let's render it, right? So we are just going to use the same image file that we had. So let's call this one as, you can just give it any name as you wish to be. So let's call this my image pixel. It's going to be the get image pixel, and I pass in my image file, then st dot right this image pixel. So let's save it and see. So the same image that now we have gotten the image pixel, right? So all of them are 25 and 20. This is how most images are. Perfect. So let's move on to the next place, and then let's get the distribution, right? So what we're doing now is that we want to get the distribution, and then from the distribution we are going to plot, right? get a distribution. So get a distribution, and then you're going to plot it. So the distribution is going to be via KMeans, and then counter from collection. So I'll paste in the code, and then I'll explain it later on, right, to save us time. Perfect. So this is the code we added. So the first function here, right, don't worry about it, it will be below so I can also check. The first function here is that you're just using image to open it, and then you're using OpenCV, right, to convert it to from blue, green, red to red, green, blue, right, which are the basic primary colors, right? Very nice. So this is very, very important to help us with processing of our image. And then you're going to convert the entire stuff to hex, right? So we use this particular function. So for I in this, get that particular hex value, and then append it to get the hex color, right? This is using pure Python. Perfect. Then the next function, we need to resize the particular image to have the same shape to make it easy. So we just use this particular function using OpenCV2 to resize the image 900 by 60 with the tabulation. Then you are going to reshape it. So we resize with this option here and make it bigger, and then we also reshape it, and we're going to return it. Then the most important code here is that you're using KMeans, right? Because this is clustering, going to cluster the image with these particular five here means the 5 different colors that you want to use, 5 different clusters. Then you're going to predict that particular class or particular cluster. In this case, this cluster, because we don't know the classification. And then you're going to get the centroid of them, right? Very nice. And then from there, you're going to use counter to get the distribution, the different count. Then you're going to sort them out, right? And then get the hex value. Then we're going to convert it to data frame. Perfect, right? So whatever is going to return, it's going to return as a data frame. Then let's check in the remaining code. So the next thing is that to apply the distribution, this function above, together with the plot. So I'll copy it and paste it to save us time. Perfect. So now let's explain this one to make it easy, right? Apologies for it. So we have created a function. So this particular function that we had here. So this function, right, to just get the image with OpenCV to convert it to this particular blue, green, red to RGB, right? Perfect. And then we have another function to convert it to hex, another function to modify and resize it, and another function to use KMeans clustering to return our result. So just applying that particular function, I'm going to load that particular image, prepare the image, that is reshape and resize them, then apply our function to it. Going to return data frame. Then when it returns the data frame, we're using plotly, right? So we imported plotly from here, which is plotly expressed as px. Then we are just going to plot it as a pie chart, right? So we are just plotly express.py, passing the data frame, the names of the data frame, which is the labels, and the value count, and the colors here are passed as labels. So this is where the limitation may come, because not all the colors are supported. Then we're going to be using Streamlit plotly chart to plot it. Perfect. Then we created 2 columns. The first one just to display the data frame with the color distribution, and another column to use plotting.bar to plot the same data that we have, right? Very simple. So let's check it out. I'll save it, and I'll go back again and let's see. Perfect. So if I come back, you can see that now our app is working perfectly as expected, right? Very cool. So here, see that we have our plot here. Very nice. So that is a basic overview of the app, right? So it is working. Let me change it and put a different color. So I'm just going to go back here, and then let's pick another color here. So let's pick this neat test. So check out neat test. It's a very nice library. I want you to tell me how far, if there are bugs or there are features you want to add to it. Okay, perfect. So that's loaded the image. If I come down here, it's going to analyze it. It's going to give us the right proportion. So it's going to be a lot of white, followed by blue, and then black, right? So let's check it out. Perfect. And as you can see, we have a lot of white. So FE is white, right? And then don't worry about this. It doesn't correspond. It's limited by plotly. And then we have the blue color. So I wish, in my opinion, we could get the actual color represented here, but there are about 16,000 combinations or permutations for the hex color, so you can't get all of the colors. I understand it. Okay, perfect. So that is it. So very cool, very nice. So you have gotten a distribution. Again, if I come down here, you can also get the distribution. I can also click on any of these keys and that particular color is going to get missing, right? That is the power of Streamlit, right? So the color that I click on is going to be omitted out, and you can expand it, you can save it, can produce, rate, plotly, right? Very nice. That is something very basic. So there is a distribution of the color, right? That is why we have a lot of white, right? The count of the white, the count of the remaining colors. So thank you for watching the tutorial. So to recap, we have seen how to build a very simple app with Streamlit, right? So all that we did was that we imported the various packages that we're using, with the core package being Streamlit. We created some utility function, one to load the image using pillow, another one to open the image and then get the pixel using pillow again, one to open the image or load the image using pillow, and then open CV2 computer vision 2 to convert it to red, green, blue. Then when we get it as red, green, blue, we will be using this particular function to get the hex value of it. Then we're going to have another function to modify and reshape our dataset or our image in this case. Then a simple function, there's a simple supervised ML function. Because we do not know the classes, we are just going to group the image, that is the arrays, the pixels, into clusters using KMeans, and then going to count it, sort it, get the hex, and then return it as a data frame. Perfect. And we apply them here. So thank you for watching this tutorial. See you another time, and apologies for how fast it was. Check the links below for some interesting material, and let me see what you are doing with Streamlit in this 30 days of Streamlit challenge. See you another time. Stay blessed. Bye.